next step is some properties of multiplying two complex numbers and dividing. So I'm going to state it without any proof. The proof is in the textbook. If you're interested, please read through that. But since you haven't done trig of that advanced trig yet, it might be something you want to come back to next year. Anyway, if you multiply complex numbers, then you will obtain another complex number. Now, the length of that complex number, or the modulus of that complex number, you could obtain really quickly by multiplying individual moduli of the z1 and z2. Similarly, when you divide, you can just divide rather than working out what z1 over z2 is, find the modulus of z1, find the modulus of z2, then divide one by the other. With the argument, it's simply when you multiply two complex numbers, the argument of the result of that multiplication, it's going to be obtained by adding the two arguments of z1 and then of z2. If you divide the complex numbers, then the argument of this result is going to be the same as the difference of two arguments, individual arguments. So let's see if we can apply it to our complex number z1 and z2. So first of all, z1 times z2, it's really simple. It's modulus of z1 multiplied by modulus of z2. Let me just write it in black so you can see better. So modulus of z1 is this number here, could be written as r, and z2 is times 4, is 4, so it's altogether 12. What about the argument? For the argument, I need to quote what's the result I'm going to use. So I'm going to quote it as the sum of individual arguments. So z1, argument of z1 is 5 pi over 12. Argument of z2 is pi over 12. That gives me 6 pi over 12, which is pi over 2. So it's 90 degrees. Okay, now we are asked to write z1 times z2 in both forms. So trigonometric form, which is called the modulus argument form. Let's do that first. So z1 times z2, this is going to be the modulus, which is 12. And then you've got cos pi over 2, add I sine pi over 2. Now, to work out the second form, so Cartesian form, you just need to work out what cos pi over 2 is and multiply, and sine pi over 2 and multiply the two results together. So cos pi over 2 is going to be 0, sine pi over 2 is 1, so the answer is 12i. Splendid. Okay, example 9. We've got to find what z1 times z2 is when z1 is 2 cos pi 15th add I sine pi over 15, and z2 is 3, which is its modulus, and then cos 2 pi over 5 minus I sine 2 pi over 5. So let's note here that this 2 pi over 5 is not an argument of this complex number because it doesn't have a plus. You have to have a plus. To make it into a plus, you need to incorporate that minus into the argument. So it's minus 2 pi over 5. And this one is cos minus 2 pi over 5. Now I'm ready to do the question. So let's do the z1, z2, the overall modulus. So you just multiply 2 by 3, 2 by 3. 2 times 3 gives me 6. Let's do the argument of z1 times z2. this is going to be pi over 15 plus minus 2 pi over 15 over 5, sorry. So this is going to be pi over 15 minus 6 pi over 15, which gives me minus 5 pi over 15, which is minus pi over 3, so minus 60 degrees. Okay, so in the modulus argument form, z1 times z2 looks like this. It's 6 cos minus pi over 3 plus I sine minus pi over 3. Now in the Cartesian form, you just need to evaluate what cos pi over minus pi over 3 is and sine pi over 3. So cos pi over 3 is 1/2, minus pi over 3 also 1/2. Sine pi over 3 is root 3 over 2. With a minus, it's going to be minus root 3 over 2. Multiply it by 6 and you'll have 3 minus 3i root 3. Which you could write like this as well, that's perfectly fine. As long as this I is further away from the square root. Example 10. In this example, we just need to apply the rule for dividing two complex numbers. So first of all, we've got to express the division in x plus I1 form. So here is our calculation. You've got root 2 cos pi over 12 add I sine pi over 12 and 2 cos 5 pi over 12 over 6, sorry, add I sine 5 pi over 6. So the modulus you obtain by dividing these numbers, so it's root 2 over 2, and then you've got to find the argument. So the argument is pi over 12 minus 5 pi over 6, which is minus 9 pi over 12, which to minus 3 pi over 4, so minus 135 degrees. So we're talking about our complex number being somewhere here. Okay, so it's minus 3 pi over 4 plus I sine minus 3 pi over 4. Reach for your calculator and evaluate this sum. So cos, they're both negative. Minus 3 pi over 4, the calculator should give you minus root 2 over 2 or minus 1 over root 2 if you remember your exact values. And sine is minus 1 over root 2i. Let's multiply it out and you're going to get minus a half I. Right, so you're ready to move on to exercise 2D of chapter 2.